Good morning. Today we are looking at slope. Another word for slope, fancier, means rate of change. It means the same thing. Rate of change is just slope, how fast things are moving. So, in words, it says the slope m of a non-vertical line, vertical being straight up and down, through 2 points, x1, y1, and x2, y2, is the ratio, we talked about ratios, of rise, change in our y-axis going up and down, and then change in our x-axis going left to right. So we just call that rise over run. And on a graph we could just count. How many are we going up and how many are we going over? If we don't have a graph, we might have to use an equation. We'll talk about that equation in a minute. Looking at 2 points. Whatever those 2 points are, we'll have to plug them in and solve for m. Alright? So let's take a look here. Before we even get into calculating our 4 types of slope. This slope, like our slope man, which is on the wall on the right side by the clock, is a positive slope. We think of slope as a person who is walking. If that person is walking uphill, we call it a positive slope. If that person is walking downhill, we call it a negative slope. If that person, I'm going to skip to the mouth here, is walking on flat ground left to right, we call that a slope of 0. But if they are going directly up and down, you can't really walk on that slope. That is a slope we call undefined. That means it's impossible. We can't do it. We can't climb straight up into the air. So another thing to note with this, we always walk from left to right like we read a book. We always read starting on the left side of the page and go to the right side of the page. Slope is the same. So here, our slope would be going uphill. We call this positive. Here, our slope would be going downhill. We call this negative. Here, our slope, our guy would be walking just flat, straight line. That's a slope of 0. And then here, we can't walk on this. We can't hang on to that line there. It's not possible. We call this undefined. You can do UND for short. Undefined. So I'd like you to pause the video and do these 4 right now on your own. Identify positive, negative, 0, or undefined. Alright, I'm going to go over them now. This one is a negative slope because our slope man here would be walking downhill from left to right, like a book. If we had our slope man on here, he would be walking straight across. This would be a slope of 0. This one, slope man can't walk on that line. This would be a slope which is really undefined, impossible. And then this one, left to right, would be a positive slope. Alright, let's keep going. Next, it says, plot the points and draw a line through them. Without calculating, tell whether the slope is positive, negative, 0, or undefined. So remember, we plot our points x and then y. So first, x is 0, y is negative 2, right there. And then x is 9, these go by 2s, 2, 4, 6, 8, 10. X is 9, so right here on the edge. And y is negative 5, negative 2, negative 4, negative 5 would be right in the middle there. And draw your line through them. This slope, if our slope man's on there, walking across from left to right like he always does, he would be going downhill, which is a negative slope. Next, same thing, but be careful. This one goes by 4s. 4 plus 4 is 8, 12, 16. So here, x, y, always in alphabetical order. X is 2, so right between 0 and 4. And negative 10 would be between 8 and 12. And then x, y again. X is 12 right here. Y is a positive 10. So I'm going to draw my line through there. Put my arrows on it. This one, our slope man, would be walking really steep uphill. This would be a positive slope. Now we are going to, instead of just saying positive, negative, 0, or undefined, it says we actually need to find the slope, meaning a number. Okay, it's going to be a fraction, going our rise first up and down, and then our run left to right. Now I like to think of slope as an elevator. In order to get, let's say you have a building, and you want to get up here to this room. You need to get in the elevator, let's say here's our elevator, and go up the elevator first, and then walk over to that room. You can't walk down the hall and just jump up through the floors. It's impossible to do that. So we need to make sure that we are taking the elevator up and down first, rise first, and then run left and right. So, like you read a book, we start on the left. Here's our elevator. We're going to go up positive 1, positive 2. So 2. And then we're going to run. We're going to go over to the room we want. 1, 2, 3. So our slope is 2 over 3. Now some of you might know what letter represents slope. Right here, it's going to be the letter M. Don't ask me why right now. I'm pretty sure it's Latin for something. But M is going to represent our slope. Our slope is 2 over 3. Over here, always start on the left. We're at the top floor of our elevator. We need to get down over here to this room. First, we have to go down, or -1, -2 floors. And we're going to get out and walk over 1, 2, 3, 4. So our slope is -2 over 4. However, we can simplify this. We can divide it by 2 and get -1 over 2. Alright, over here, here's our elevator starting on the left. We always start on the left. Always, always, always. We're in our elevator. We got to get down here to the main floor to get out to our car. I got to go down 1, 2, 3 floors. And then we get out and walk over 1, 2, 3, 4, 5, 6. So our slope is -3 over 6. But we can simplify. I'm going to divide it by 3. So we'd have -1 over 2. And then our last one. There are no points on here, but we can find some nice points. Wherever we cross two, they're like the corner of a square here. So this would be a nice point because I can count to it by ones. This one, not so good. We can count 1, but I don't know what that is negative. So as I follow this along, there might be a good point, or right there. It doesn't matter which points you use, you'll get the same slope. So if I'm in my elevator here, I need to go up 1 floor and get out and go over 1, 2, 3. Rise over run. That's my slope, 1 over 3. If I used this elevator to get to this point, I would also go up 1 and over 3. Same thing. Our third and final way to find slope is to use our 2 points. Now we know how to label our points x and y, but we have a first point and a second point. This is the first point I see, so I'm just going to label it the first point. This is the second point that I see, so I'm just going to label it the second point. And all we have to do is plug it in. It says m equals y2, which is -4, minus y1, which is 6, and then on the bottom x2, which is 5, minus x1, which is 0. You have to do it in this order. You can't do the x's first, always the y's on top, because that's our rise over our run. -4 minus 6, they're all negatives. That would give us a -10. 5 minus nothing is still 5. So if I simplify that by dividing by 5, we get -2 over 1, or just -2 is fine. Let's try the same thing. Label our points. X, Y, that's my first point. X, Y, that's my second point. And then our plugging it into our equation, y2, which is -2, minus y1, which is 2. Then x2 minus x1, 5 minus 5. Negative 2 minus 2 is negative 4. They're all negatives. 5 minus 5 is 0. Now if you look over by the clock in my classroom, we have two posters, or one poster, that says no, and it says okay. To solve, or to figure out whether our slope is 0, it's okay, or no, which would be really undefined, because we can't have that, it's not possible, we need to look at this poster. We have the 0 on the bottom. 0 on the bottom forms the word no, can't do that, so our answer, our slope, is really undefined. That is our answer. It's not 0, it's undefined. Then, same thing here. Label our points, x, y, first point, second point, and we're going to plug them in. It says y2 minus y1, so 4 minus y1, which is also 4. And then on the bottom, x2, which is negative 3, minus x1, which is 0. Well, 4 minus 4 is 0. Negative 3 minus nothing is still negative 3. So this one on our poster is okay, so our slope is just 0. Anything divided by 0 is 0. And our last one like this, here's x, here's y, first point, here's x, here's y, second point. So, plugging it in, y2, which is 6, minus y1, which is 3, and then x2 minus x1. x2 is 4, minus x1, which is a negative 2. Be careful. This x is negative. The equation also has a negative, so those two negatives make a positive. 6 minus 3 is 3. 4 plus 2 is 6, but we can simplify that. Divide by 3, and we get 1 over 2. Now, it looks like we have two more, but these ones are actually just a tiny bit different. We're going to still plug in everything like we've been doing, but now we need to find the coordinate. We need to figure out what x is, because they're telling us what our slope is. Wow, that was bad. Our slope right there is 5/6. So we're still going to label our points, x, y, first point, x, y, second point, and we're going to plug them in. So it says m, which is 5/6, equals, then it says y2, which is negative 1, minus y1, which is 4. Then on the bottom, x2 minus x1. x2 is 6, minus x1, which is just the letter x. Now we can simplify this. It says 5/6 equals, well, negative 1 minus 4, they're all negatives, so that's a negative 5. On the bottom, I can't simplify 6 minus x. But if I think back to chapter 3, this looks really familiar. Remember doing some cross multiplying? That's what we're going to do here. We are going to cross multiply. But because this is adding or subtracting, we need to distribute or put parentheses around it. So first, 6 times negative 5 on one side, and then on the other side we have 5 times 6 minus x in parentheses. So 6 times negative 5 is negative 30. If we distribute on this side, 5 times 6 is 30. 5 times negative x is negative 5x. We just multiply. Don't forget to multiply both terms, okay? So now we're just going to solve this. We want to get x by itself. We're going to do our order of operations backwards, get rid of addition or subtraction. So I'm going to subtract 30. Those are gone. If I owe you $30 and now another $30, I now owe you $60. They're all negatives. Equals negative 5x. And then this is really multiply. The opposite of multiply is divide. Two negatives make a positive there. 60 divided by 5 Plug it in your calculator if you're not sure. It should give us 12. So that missing term right there was 12. I think there are 2 problems like this on your homework. We're going to do one more just to make sure we're good at it. One thing to note, if they gave you a slope that was just like the number 5, you could make it 5 over 1, so you could cross multiply. I think there's one like that on your homework. This one we're going to label xy first point, xy second point. And our slope is a negative 7/9. I'm going to put the negative on the top. You could pick if you want it on the top or the bottom, but it just goes with one, not both. Oops. So plugging this in, m, which is our slope, which is negative 7 over 9, equals y2 minus y1, so negative 3 minus y. Then on the bottom, x2 minus x1. Again, 2 negatives there make a positive. So when we simplify this, we have negative 7 over 9. Negative 3 minus y we can't simplify, but 0 plus 9 is just 9. So let's cross multiply. Keep that part in parentheses. Negative 7 times 9 on one side, and then 9 times, or in parentheses, negative 3 minus y. 7 times 9 is 63, and they're all negatives. Negative 3 times 9, 9 times 3 is 27, but it's negative. 9 times negative y is really negative 1, so it's a negative 9y. And then we're just solving for y. Get rid of your addition or subtraction first. I'm going to add 27. So I have negative 9y. And these are different signs, subtract them, or just plug negative 63 plus 27 into your calculator. 13 minus 7 is 5. 5 minus 2 is 3, so we get 35. I made a mistake. This is 36. 36. And then last, the opposite of multiplying is divide. Divide by negative 9. 9 times what is 36? It should be a negative 4. I know those ones were a little bit tricky, but make sure you just follow the same procedures. Plug it in, cross multiply, and solve. Last slide here. This one is actually on your homework, so pay attention. It says the graph shows the cost in dollars to mail a letter that weighs 1 ounce during certain years. Determine the time interval during which the cost to mail a 1 ounce letter showed the greatest rate of change. First thing I said today, fancy word for slope is rate of change. So which one had the greatest or the most positive slope? So which one would be walking uphill the fastest? If we had a man on here that was walking, or a woman, walking, 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 whoa, this part here seems to be going up steeper than all of the rest. So it says during the time interval, from here to here, this is 2001 to 2002. If we wanted to find the slopes between all of these, we could. We could count rise over run, rise over run, rise over run, rise over run. But you can see right here, this one rising is going to be the most, the greatest. Then determine the time interval during which the cost to mail a 1 ounce letter showed the least rate of change, or the least slope, the flattest slope, or a slope of 0. So if you look, you can look straight at the lines. Which one's the flattest? To me, it'd be one of these middle ones. And if you're not sure, look at our points. This one's going from 0.29 to 0.32, so they went up by 0.03. This one's from 0.32 to 0.33. They only went up by 0.01. That's pretty close to 0. This one from 0.33 to 0.34. Ooh, that one's also only 0.1. And then from 0.34 to 0.37, that went up by 0.03. So, which time interval showed the least slope, or the flattest slope? It would be these two right here. You could say from 1995 to the end here, which would be 2001. That was the flattest slope. However, this time interval was longer. It was from 1995 to 1999. If we were to actually find slope, rise over run, we just did the rise. Our run here would be 4 years. Our run here would be 2 years. This one is actually going to give us the smallest or the flattest slope because it's over a longer period of time. So it would really be to 1999. Last one. Not really solving anything here, just looking at interpreting a graph. It says a student commutes from home to school by walking and by riding a bus. Describe the student's commute in words. So here's our time as time is going on, more time is passing, and here's our distance, how far they're traveling. This first slope here, the time, quite a long time has passed, but they haven't gone very far. So during that time, I would say, if you're going not very far, but it's taking you a long time, you are probably walking. Then, if time is still going on, but you're not going anywhere, you're staying right here, I would be just standing, or maybe a better word, waiting, because you're waiting for the bus. But then, not much time has passed from here to here, but you went, woo, look how far you went. I would say, if you're going pretty far, but not very much time has passed, you're moving pretty quick, you're probably on that bus. So you're on the bus. There is a problem on your homework where you have to describe what is happening. It is different than this problem, though. So make sure you get a homework assignment from me. It is this worksheet right here. Good luck.